Everybody, it's Tyler checking in with another Behind the Bot here at the Texas Cup. I'm here with team number 3708, Iron Eagles, coming in out of Austin. And we're going to be taking a look at this robot, of course, going through the entire scoring mechanisms, some cool auto-aim sensors going on. And to help me out with that, I have Samuel, Donovan, Evan, and Robbie. And team's doing really well so far. Can't wait to see how they do more. Just had a 500-plus point match, so very exciting for that. Let's check out more about this team all here on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. If your team or organization is hosting an off-season event, did you know you can stream it right here on First Updates Now for free? Events that stream on First Updates Now receive an additional 25 to 100% additional viewership because we help you promote your event on a large platform. If you're interested, reach out to us on any of our social platforms, on Discord, or send us an email at admin@firstupdatesnow.com. Let's get your off-season event streaming on First Updates Now. Hurry, dates are booking fast, and we take first come, first serve for all our events.
So Samuel, start us off here. We're going to be talking about the intake going in the hopper. Tell me a little bit about just some of the concept, design, and any iterations you might have went through as well.
All right, yeah, we had several iterations with our intake, most of them having to do with this ramp tip. As you can see, it pivots along this intake right here. So this all moves up and down, and the reason we did that is so it can be adjustable with the tiles. In our models, we didn't model the ground, so we wanted it to be able to adjust as the robot sinks into the tile, so it can get the perfect lift. Following that, there's these two sets of wheels. They're hooked up to this motor by a chain, and we added this third row to stop any stalling points, so it can go smoothly into the hopper. Several iterations that we had is on this third row, we had a ton of beater bars, little like pushers and stuff, but that would cause a lot of popping up. The ring would exit the hopper completely. So then we started putting roofs, like a ceiling right here where my hand is, and that kept causing even worse jams. So we figured, let's put this motor here, let's gear it up, and it works perfectly smoothly. We haven't had a lot of problems with it anymore.
So just looking at the intake real quick, so you have wheels here, here, and here, but not in the middle. Like, how did you get the spacing down, like, and figure that out?
Yeah, we did all the spacing through modeling. We have our ring like modeled through this ramp, and you would see where the contact points are to make sure that the ring is always being touched and not like let go. So we don't want it to fall back down into the intake. And based on that, we realized these have to be a lot closer together so it can fall smoothly down here. If we had the same spacing, they would kind of keep going out and it would not fall in the hopper.
Yeah, makes sense for that. Donovan's going to be talking about the shooter a bit more. So really what I'm interested in hearing, of course, the concept and design. You guys got a big compliant wheel on here, but talk to me a little about like how did you figure out the compression to use on the rings, that sort of thing as well.
Yeah, of course. The shooter itself has been pretty locked in since day one. We've done some marginal changes concerning this motor right here and this servo. We wanted a faster speed so we can shoot faster on the servo, so we went to a super speed servo, not very much torque. And this also, we used to have a gear up mechanism that was really loud and it caused a lot of vibration,
all right,
which didn't work obviously. So we went to a 1-to-1 ratio and we just go straight into the wheel now. As far as the compression goes, we kind of just guessed and checked.
Yeah.
We guessed, we have a big box of wheels and we went through wheels, different types of wheels, and we found that this one will work the best. And then we went through different speeds because speed with this wheel will cause it to expand. So that allows us to change our compression on the ring, allowing us to shoot farther and give us more control.
One last thing to ask is for the material on here, what made you choose this type of is this 3D printed or is this like a dowel rim?
It's 3D printed. The bottom metal ramp is also custom made, but this is 3D printed. We had to go through a lot of different iterations on that because we couldn't get a good print on our printers at the school. So we had to go outside of the school with our mentors to print that.
Makes sense. Thanks for telling us more about that. Next thing I'm very excited to talk about, of course, your wobble goal mechanism, Evan, but then you got this baby arm, as you call it, right, on here.
Sir.
So talk to me a little bit about both of these as well.
So our wobble goal mechanism is fairly straightforward this year. It comes down like this. That was its starting position in auto, and then, of course, it's going to be like this in teleop. It's got these two little claws right here that move together. We use two high torque Savox servos in order to really lift that wobble goal all the way up in case we need to. It's got a hard stop here. We figured out one of our early iterations was just this without the hard stop, but we figured out later on in the year that we wanted to have that hard stop in case we went too low or it bent into the ground. So our baby arm here, though, is really interesting. We really only use it in auto when we have a 4 stack of rings because, as you know in this game, you're only allowed to have 3 rings in your robot at once, so you can't just run up to the 4 stack and grab them all, although it's very easy to do so. So we actually have this ring, which there's no rings right here. We have this arm which comes down to the height of one ring, fits underneath it, so that when we back up with this arm extended, it just pushes that 4-stack out into a neat line, and we only go for the first 3, and then we pick it up, and then we come back for the 4th one. So
that makes a lot of sense. And this kind of, we'll segue the next question to Robbie here, talk about from sensors and that sort of thing. The first thing I'll ask you before is, do you have any sensors that determine like how many rings come in to make sure you only do grab 3, just to kind of go off of that? And then love to hear more about your actual vision system, that sort of thing.
Yeah, so we don't actually have anything to determine the number of rings. We tested out a prototype to do that.
Sure.
But we didn't have space in the hopper to add it, so it's just, we don't have it. But then for our, one thing we experimented with this year is with our auto aim. So we have a secondary camera that detects the goal. It looks for the largest blobs of red originally, but we changed it to white. We have a name, we call it the 5-factor heuristic algorithm, but it just looks for the white piece of paper on the goal to detect where it is, and then it can apply offsets for where the power shots are. And then we added this LED light as an indicator for our drivers of when it's aimed or not.
Well, it's been working very well. Obviously, you guys just had a huge match, so 37-08. Thanks again for taking the time to speak to us about your robot. Good luck here at Texas Cup. Can't wait to see what else comes out of your team. Good luck the rest of the way.
Thank you.
thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.